For the first question, I had the expression in logarithmic form and I had to make it in exponential form. And to make it in exponential form, the base stays as the base and the product becomes the exponent and the argument becomes the product. So I had b to the power of c is equal to 11 over 12. I used the definition of logarithms to solve the first problem as well as the second problem. And for the second problem, the 6, which becomes the base b in the logarithmic form, and the power that it's raised becomes the product, and the product for the exponential form becomes the argument. So I'm left with log base b of 6 of a equals b. For the third problem, I figured out that 4 to the power of something will never give me 128, so I had to rewrite it in exponential form. So I am left with 2 to the power of 2 is equal to 4, and 2 to the power of 7 is equal to 128. And then the log 2, then the exponents of both of them give me my answer, which are 7 and 2. 7 over 2, or 3.5, stands for x. For number 3, I had to solve for x, and 216 to the power of x has to give me 6, and I know that 6 raised to the power of 3 is equal to 216, but I have to put an x, so the 6 in both sides can cancel out, so I'm left with the exponents of both sides, which are 3x is equal to 3, and then I solve for x, and then I solve for x, and I am left with x is equal to 1 over 3. And for number 4, I have a reciprocal, and I know when I have a reciprocal, the answer for x will be a negative exponent or a negative number. So I know that 7 raised to the power of 3 is 343. And as I mentioned before, since it's a reciprocal, and if I want to eliminate the 1, my exponent will be negative, so the positive 3 turns into a negative 3, and that's my answer for x. And for number 4 for 3D, I use the property of inverse, which states that if the number before the logarithm is the same as the base b of the logarithm, the number will be x, and x in this case is 17, so my answer is 17. And for number 4a, I use the quotient property, and I distributed log, that's the word, I distributed log to both q and p, but since p has an exponent of 6, the 6 runs to the front of the logarithm, and since it is since I'm using the quotient property and it's a division, the sign for this expression will be a negative. And for 4b, I use the product property, which treats multiplication, and I did the same. I distributed log to both n and m, but since there is an exponent of 2 outside of the parentheses, it means that the 2 will be distributed in both of the n and the m. It can be written in both forms. I can do 2 log of n plus 2 log of n, or 2 and the parentheses of log of n plus log of n m. For number 5, I used the quotient property, but now it's the other way around. So I have to condense the expressions. And since both have a natural logarithm, I put natural logarithm and then I open the parentheses and put t divided by, oh, I put a natural logarithm where I shouldn't have. Divided by s, but since there is a 4 in front of this expression, it will become an exponent, so I'm left with natural logarithm of t divided by s to the 4th power. For 5b, I used both quotient and product property since we have subtraction and and addition and subtraction again. First, I condensed the first expression and I am left with 2 outside of the parentheses log of 2x divided by y, and this will become the 2 will be distributed as a exponent on both 2x and y minus, and now I condensed this one, and since it is addition, I will use the product property, which will be multiplication, so it will be log of 3 times 5 to the 2nd power. Now I condensed all of it, and as I said before, I distributed the 2 for the next step. So I'm left with log of 2x squared divided by y squared divided by 75, because I already condensed the 3 times 5 to the 2nd power. And since I can simplify it more, I combined the 75 and the y squared. So I am left with log of 2x to the 2nd power divided by 75y squared. I did number 6 on paper and I will upload a picture of it in Google Classroom, but I use the change of base property, which states that log b and to an exponent is equal to log of any base. So I put x, log of x to the a divided by log of x to the b. In this case, I changed the base of 8 for the base of 2. So it would be log base 2 of 1000 divided by log base 2 of 10, and I will see if that is equal to log base 2 of 10. And I know that 1000 is 10 to the 3rd power. So, and 2, and since the base of the original expression is 8, I know that 2 to the 3rd power is 8, and I use the formula, so it will be expressed as log base 2 of 10 to the 3rd power divided by log base 2 of 2 to the 3rd power is equal to log base 2 of 10. Now since both of them have an exponent of 3, I put the 3 in front of the logarithmic function, and since they are dividing, they cancel each other out, and the expression below has the property of inverse, so it becomes 1, and we are left with log base 2 of 10 is equal to log base 2 of 10, so it is correct. For number 7, I know that 3 times 5 times 6 is equal to 120, so the logarithm, the answer for this one would be log of 8 of log base 8 of 4 plus log base 8 of 5 plus log base 8 of 6. I use the product property because it is adding and multiplying, so it's multiplication, sorry. And no, wait, it is addition, and we know what all of these logarithmic functions stand for, which is a, b, and c, so my final answer would be a plus b plus c. For number 8, I use the definition of logarithms again. So I know, since there is no visible base on either one of the logs, we know that it's 10. So the 10 is, I put the 10 before both of the logarithmic functions and they cancel out. So I'm left with 4k minus 5 is equal to 2k minus 1. Now I combine like terms and I know that 4k minus 2 is 2 and negative 1 plus 5 is 4. And I have to solve for k. So I divide by 2 on both sides and I am left with 2. So k is equal to 2. And 8b, I divided by negative 6 on both sides and I am left with positive 4 on the right side. And now I use the definition of logarithms again. So I am left with 3 to the power of 4 is equal to x minus 3, which is equal, and 3 to the power of 4, I know it's 81. So I am left with 81 is equal to x minus 3. And I add 3 on both sides, so I am left with x is equal to 84. For 8c, I use the quotient property because we have subtraction. So I condensed the left side of the equation and I am left with natural logarithm of negative 3x minus 1 divided by 7, because I use the quotient property, is equal to 2. And I want to get rid of natural logarithm, so I know that e is the inverse for natural logarithm, and since there is a 2 on the other side, the 2 becomes an exponent. So now I am left with negative 3x minus 1 over 7 is equal to e to the second power. Now I have to solve for x, and I added, I multiplied 7 to the other side because it's dividing on the right side, so it's multiplying on the it's dividing on the left side, so it's multiplying on the right side. So I am left with a negative 3x minus 1 is equal to 7e to the second power. Now I have to keep solving for x. So I add 1 on both sides and then I divide by 3 on both sides. So the final answer is x is equal to 7e to the second power plus 1 divided by negative 3. For 8d, I use the definition of logarithm, so I am left with log base 4 of 1 is equal to 2x plus 3. And I know that anything with the exponent of 1 is equal to 0, so 0 is equal to 2x plus 3. Now I solve for x, and I am left with negative 3 halves is equal to x. For the last one of 8, I use the definition of logarithms again, but first I added 5 on both sides. Then I applied the definition of logarithms and I solved for n, so I am left with log base 11 of 59 plus 8 is equal to n. For my last problem, which is number 9, to solve for the x-intercept, I turn the y into a 0 and then I solve for x. I use the definition of logarithms in the process, and I use the definition of logarithms in the process. First, I subtracted 3 from both sides, and then I applied the definition of logarithms, and I am left with 5 to the power of negative 3 is equal to x minus 1, and 5 to the power of negative 3 is 0.008. And since I am solving for x, I have to add 1 on both sides, so the x-intercept is 1.008. For the y-intercept, we have to turn all x's into zeros, but I could not solve the function, so we don't have a y-intercept, it's undefined.